Hey, what's up, guys? So today is all about bridge building. So this is a neat part of STEAM. We have the sciences, we have technology with our drones that we've been doing, we have engineering that is going on here. Engineering really is art. Everything about engineering has cool aesthetics to it, things like that. And then, of course, tons of math involved with our geometry and measurement, just an understanding of how shapes work and their strengths and weaknesses. And so what we're going to do is I want to walk you through this PDF that you have in Notability and just give you insight on what your tasks are going to be with this. This video is something that you're going to not get through all in one day. We're going to be stopping it at a certain point, class-wise, and you're going to be working, and then the next day we might watch more of it. So this is sort of an ongoing video that you're going to access at different points throughout this PDF to understand what to do and get a little bit more details into your task. So let's take a look at the document here. We have building a bridge can't be all that difficult, can it? Anyway, because of your successful drone mission, you've received communication from Aquonia requesting a bridge be built. So now you can work together to survive in this new world. Pretty sweet deal. You figured out non-soil ways of sustaining yourself with food. Maybe they have other things that would benefit us. So to accomplish this task, you'll have to undergo some STEAM investigations with bridge building. So I want you to complete each challenge, and then we'll take pictures of some different work as we go. Probably just at the end is where we'll want to officially document your final challenge. So the first thing is going to start off with teams of 2 to 3 people, no more. And I also don't want you working by yourself with this one. I want you talking, collaborating, and working together on this. And so 2 to 3 people, and your first task is this, to build the longest bridge. However, you have some different constraints. So with this challenge number 1 of building the longest bridge, this is building a bridge without a load that will not fail. So let's talk about some vocabulary. So fail means it breaks. Okay, in real life, it breaks and people get hurt, injured, maybe they die, which would be bad. And so let's talk about some other vocabulary before we get rolling with this. Up here in this vocabulary section, you can see that we have beams. Beams in this case are our rods, our Connex rods. We have load. A load is anything putting weight on the beam or on the structure itself. We have a dead load, and a dead load is the weight of pretty much the bridge on itself without anything driving over it, sitting on it, things like that. It's just the dead load that exists. Then we also have a live load. A live load is the load of your structure when something is on it. So do you have a heavy live load? How much live load can your bridge or structure handle? With your dead load plus your live load, can it support itself without failure? That type of thing. We have the word span, like how far does it go across? We have conditions like bending or maybe sagging, depending on the situation. How rigid or sturdy is your structure? Fail and failure. Strength, your design, different design specifications. So like how long are things, how strong are they, that kind of thing. And then the term structure. This is a structure made up of multiple materials or parts. All right, so let's get into the challenge itself. Your first challenge is build the longest bridge. Now this is without any load on it, and make sure it doesn't fail. You can only use 15 Connex rods, but you can pick any size. If you want to use red, if you want to use yellow, whatever, gray, but you can only grab 15 of them. 15 connectors of any type. So these are connectors. You can grab 15 of any type that you want, but they all have to be the same. 15 any type. Well, I don't think those ones need to be the same. You can mix those up if you want. Grab some tape. The tape is only to hold down the ends. It is not for the actual construction itself, only for the ends, no cheating. All right, after you build and use up all your pieces, then I want you to use the tape measure and measure the distance of your bridge from one place to another. Record that down, and I want you to take a photo of your longest bridge, okay? All right, let's take a look at challenge number 2. Challenge number 2 is also a longest bridge. However, we are going to put on a small load of 100 grams in the center of it without failing. So same thing, our 15 Connex rods, our 15 Connex connectors, and the tape to tape down the ends. You don't need to really build anything different. You're just going to test what you have. If you want to adjust something a little bit, understanding that now you're putting on a live load, you can make some adjustments real quick. So we're going to go ahead and put 100 grams on. Those will be over there, labeled for you. So you'll borrow that, put it on, take a picture, see what happens. Hopefully it doesn't fail. And then challenge number 3 is also longest bridge. So maybe you don't do anything. Maybe you do some revisions. It's going to support a small load of 50 grams. However, you can have 0 sagging or bending, okay? So if you want to claim you have the longest bridge, that's fine. But if that 50 grams creates sag or bending, you no longer have the longest bridge with no sagging or bending. And so basically you're disqualified. But either way, mark down your measured distance in centimeters, take a picture of it. When you take a picture, like get down eye level with it and take a picture that way. So that way we can really see if there's sagging or not to verify if you're the winner or someone who is not the winner. I forget what that word is. Oh yeah, loser. No, that's okay. It's okay to fail and lose sometimes. All right. So you're probably going to pause the video right now, exit out, go ahead and do all that stuff. Use the PDF and work through the PDF and take care of that. Once you're done, come back to this video, find this spot in the video, and let's talk about investigating 2D shapes. All right, so we're back with the next part of our investigation. This is investigating 2-dimensional shapes, rectangles and squares, okay? Should be shapes, rectangles and squares. Your objective is to investigate the forces on rectangles and square shapes. A force is some sort of pressure. When you put pressure on something, there is a reaction that comes back at it. That gets a little bit more higher level, but we're going to investigate the basics of forces on objects. This one is done as a team of 1. I want you to do it by yourself individually, but have discussion with your table group. So there will be conversation going on. Your vocabulary for this section is stable, unstable, strength of structures, strength of your materials. So structure is the whole thing. Materials are the little pieces inside. Your frame, structure, compression, tension, shear, distort, and stress. Stress is anytime you see something that is not normal. So like this, if I squeeze it, you can see I'm like putting stress on this piece right here. You can see it's bending. So that's stress. Some of those other words. So we have compression. Compression is when you push together and you see what kind of stress exists. Some other words like tension. Tension is when you pull apart and you see what happens, okay? And then shear is when you take the top and the bottom and you push one direction with the top and the opposite with the bottom and you see what happens. So we would go like this. I'll let you do that as part of your own investigation. And then distort if something is distorted, it's being manipulated, it's changing. You can also like torque and twist and see what happens when you do things like that and how the shape is affected. Anyway, what I want you to do with this is I want you to grab these materials. So your first set of materials are 4 blue, 4 red, 4 gray rods, an assortment of connectors for creating squares. The rectangle should be made using blue, only 2 blue, and then either red or gray, okay? But you automatically are gonna have 2 blue for one of the sets of parallel sides. So task 1, here we go, is the squares. I want you to construct 3 different size squares, 3 different size squares. Each square has to have a certain color. So for example, I might have a yellow created square. I might have a red, one made out of reds. I might have one made out of blues. I want you to make 3, okay, to see how even size affects things. After each build, apply external force, okay, pushing and pulling on various points. And I want you to notice, I mean, and even like try twisting, doing different things. I want you to notice what you see, what stresses exist. What are there some times that you push or pull where that area is stronger or a certain area is weaker? I want you to notice those things. And then in the written response, it says, what did you notice? Use the vocabulary above to help you explain. So like what strengths exist, what weaknesses in the square design. I want you to tell me and use that vocabulary. So when I compress on the corners, this is what happens. When I pull on the corners, this also happens. Or put it all in one big sentence. When I do this, and this is something that happens in all situations. Whatever, just jot down your notice using some of that vocabulary. Task number 2 is rectangles. I want you to construct 2 different size, not squares, rectangles, using blue rods, okay, as 2 of them. So 2 sides will be blue, and the other 2 will be 2 other colors. We said either red or you're using gray, okay, to make that rectangle. After the build, again, apply all those external forces on the shape, try twisting, and again, do a written response of what do you notice. And then task 3, I want you to combine your squares with another group of people's squares. So maybe it's one person next to you, maybe it's a couple people. Try combining squares. You may have to adjust some of your connectors, which will get you prepared for later. And I want you to notice what happens. So do some like external force tests on that when you create a chain, and take notice, like, does this help? Does it hurt? Does it do nothing? Try moving it around, do some like shear tension tests and things like that, or shear force tests and all that, and just see if it adds strength to it or doesn't do a darn thing. Either way, jot down your notes of what you notice, okay? This is that point where you're gonna pause again and do all those parts of the PDF, and then when you are done with that, I want you to put all those pieces away, and you're going to move on to the next task, which will be investigating triangles. Okay, so go ahead and pause, and I'll see you when you're ready for the next set of tasks. All right, here we go for your triangle section. So hopefully you experience some good noticing with the squares and rectangles. Let's talk about our favorite 3-sided shape called triangles. Here's the materials that you're gonna need. I want you to go ahead and just grab some different size rods. I don't wanna tell you specifically which ones, because if you're doing a right triangle, you might need certain sizes. If you're doing an equilateral triangle, maybe you'll need certain size. If you're just doing an acute triangle, you are going to need some different sizes. So either way, the materials that you're definitely going to need are some rods, and then you're going to need 3 yellow, 3 red, and 3 white connectors, just so you have a mix of different possibilities. If you need something different, honestly, go grab it. This is a team of 1, but of course, collaborating with your table groups. All right, now, after each build, you're going to, again, do all those different force tests. So your overall task for triangles is, I want you to construct a right triangle. And remember, a right triangle would have a 90-degree angle, and then you would have this piece, a piece, going straight across, okay? This is our hypotenuse. So here's a right triangle. So I want you to make a right triangle, and I also want you to make some sort of other acute triangle. So 3 acute angles. So right triangle, and then somehow pull off an acute triangle. Try combining multiple triangles, like the picture you can see here where it says try joining multiple triangles. You can join with another couple people or whatever and collaborate on that part. But I want you to apply those different forces. And so we have a vertical force, which would be pushing down from the top, and actually set it down on the table and like push down and see what happens. I also really want you to be comparing with the square. Is this stronger? Is this weaker than a square in your opinion? Try some different like shear things, even those shear force pushing opposite directions. Test the strength of this longer side, this hypotenuse, and see if you notice anything with that. Some lateral means sides. So push on the sides and test some lateral applied force. And then when you join multiple triangles together, like the picture there, does that help with its strength? Does it do nothing? What are your thoughts on that? I want you to do a written reflection and share what you notice. And then make an official conclusion reflection of which is stronger, squares or triangles. All right, go ahead and pause and take care of that investigation. And then when you're ready, we'll take a look at 3D cubes next. All right, 3-dimensional cubes. So now we're getting into actual bridge stuff here. But those other things were really good foundations. So here's your task and your objective. Now this is a table group as a team. Notice what it says in orange here. So it's your entire table group is working as a team, and you're gonna be actually collaborating with the table next to you. So you can see in the picture of like our classroom over here, in this picture, these are the tables that I want working together. And so you're gonna work on building across to the other table. And so maybe you'll build half, they'll build half, and you'll then attach them together, that type of thing. That's how you'll collaborate. So let's go into the details of this. So your objective, use Warren Truss construction, you'll see the image of that below, to engineer a bridge, demonstrating your understanding of cubes and triangulation, okay? And so each table is gonna work together to create a bridge to the table next to them. I want you to look at the pictures below. I'm not gonna tell you all the materials you need. Just look at the pictures in the PDF there and determine what materials you need. So your first challenge here is gonna just be analyzing those images and notice things about that. And then overall here's your main challenge. Dun, dun, dun. Build a bridge from your dome to the other community. I want you to work with your table group, construct a cube. So very first thing, just make a cube. Now, there are some little details with how these connectors need put on that you'll sort of figure out as we go here. But I want you to build a cube with your table group. So work together, build this. Do a little bit of strength tests and put some force on it and see if you notice some different weaknesses, because technically a cube is a bunch of squares. And so we already learned that squares aren't really the strongest shape. And so, maybe that's a bad idea, I don't know. So anyway, we have a cube. So you're gonna build this, okay? After you build the cube, then I want you to play with triangulation. To do that, you're going to use these red rods, and you can see that in the next picture. And you're going to create some triangles within the cube, okay, like that. This is called triangulation. Technically, I just made 2 triangles. Makes sense, right? We know triangles are pretty strong shape. So after you put one on this side and one on this side. Test the strength. Like, did that do anything to it? What are your thoughts? Once you get this done, then you're going to utilize that image of Warren Truss construction, okay, and start combining these together with the other team and build a bridge to the other community, Aquonia. Once you get your bridge from one side of the table to the other, I want you to take a picture of that, upload it to this space below in your PDF, and then you're all set with that. However, as you build these, I also want you answering these questions. So we're making this cube, and I want you to answer these parts here in the PDF that you see that I highlighted. How many of each piece do you need for one cube? So I want you to like count them up, record it down. How many yellow rods, how many blue connectors, how many red rods? Oh, so there we go. This and one more, so 2 red rods. When I connect this with another cube though, how many of each piece is that? And don't get tricked, because when I'm combining cubes, I'm pretty sure this side is sort of the side of the next cube. So is it really this times 2 or not? So be careful when you figure that out. And record that information down as well. All right, have fun with this, work together, make sure everyone is doing their part. Good leadership as a GM crew member really looks like this. Asking questions, how can I help? Who wants to, does someone want to start building this cube? Does someone want to build these? Someone want to take care of the triangulation parts, things like that. Asking questions to figure out roles in the group. How can you all collaborate and work together? All right, once you're done with this, I want you to upload the assignment in Schoology and we'll check it out and see how you did. And then your bridge itself, you can just set that aside in the room and we get to take it all apart next time. Won't that be fun? All right, have a great day. Good luck. Let's get to that other community.